That's what always happens. That's what I always do. Just ignore me. This will be a process talk. So it's like more of going through the steps of why we need to have continuous deployment and delivery in our daily lives. Good. So we're all in the business of software, I hope. Like, that's what we do. Most of the things that we do because we get a requirement or a need from somebody, and we need to deliver on that. So basically, we get an understanding of what somebody needs. We create like an expectancy, something they're expecting to receive, and we ship on that. This thing that we do is cycled, it's time-boxed. You can say that from the beginning of a request up until you finally deliver it to an end customer, you have one time box. That's what we call cycle time. So when delivering software, you have a cycle time. And if you have it shorter, it's better. There's a lot of reasons for that. The most important ones are inventory. The more you keep your code unreleased, the older it gets and the more expensive it gets to fix it. That's one of them. The second thing is that the people that are requesting stuff from us, they're people, they want them. So the more you give it to them, the happier they are. And we want to make them happy. Here, so bear with me. And bear with me while I stop everything. There's a button here that turns it off. Okay, so if you have a 2-week sprint, this is like arithmetic, and you deploy and deliver after a 6-month release, your cycle time is 6 months. It's not 2 weeks. You're lying to yourself. If you have a deployment every sprint, it's still 2 weeks. If you have a deployment 5 times a day, it's roughly 5 hours. That's automated. Well, Amazon deploys every 11.6 seconds. So it's like their automated system is deploying something every 11.6 seconds on a range of 160 products. So it's not going to be 60 seconds for the shop, but it is going to be something for a customer every roughly 6 times per minute. So that's something nice. So how do we decrease this in our environment, let's say? You can just do less. It's like you can basically say, I deliver every 12 minutes because I deploy after every label changes. So my application has like 100 labels. I'm going to change one label and deploy it. That's not exactly fun, but it is cycle time decrease. So we can release without testing anything. That's also something that is done like on a daily basis. We can automate as much as possible everything from version control, and I'm going to get into that later a little bit about automation of version control for releases, and deploying it to production. That's not something required for this process. So like having an automated platform from end to end doesn't imply that you're going to take it to production every time. You can stop it along the way. It can be stopped in acceptance testing. And then production deployment can be a manual process. You're still not cheating. It's OK. So there's no issue with that. OK, continuous is as in all the time. So you're going to need an automated system for that, not a person that's going to do that every time. Because like we commit at 3 a.m. That's how we are as people. So that means that somebody has to check that at 3 a.m. Deployment means deploying it somewhere, not necessarily in production. It can be any of your environments. And pipeline is as in a series of flowing steps. I don't know what other description I can have for that. So this is basically an evolution. This is not something new. This is something that is being done for a lot of time. You can see like deployment and delivery pipelines in Fred Brooks's book in '78. They've been doing this forever. But this has been done only in constrained environments. We have reached a point where you can do this in basically any language on any platform without any problems. And it helps. As a short intro, this is how a normal marketing diagram looks for this thing. So you're going to need agile development because there's no point in building this if you're going to use 4 teams that deliver code on a floppy disk every 2 weeks. And then you'll need continuous integration, you'll need continuous delivery and deployment somewhere, not necessarily to production. Okay, it's better, but why? There's this thing that happens to people, like, when you shave as a person, the more frequently you shave, the easier it gets. It's the same with like baking cookies. When you bake cookies, or when you, do some semi-autonomous stuff like washing your car, every time you do it, you get better at it. And there's a point you reach where there's no problems there. So you're going to be able to do that without thinking about it. So every time you do a deployment, it gets less riskier. This becomes a known and stable process. There's a lot of things we don't know about our deployments. Even if you're a lead, if you have deployment engineers or deployment specialists, you might not know that on the specific version of Amazon Linux you're using, you need to do 4 things before you deploy. Your deployment engineer will know that, but you won't because you're using Windows, and there's no need for that. And it forces you to think about your environment. When you create a deployment pipeline, you need to take into consideration every aspect along the way. You start thinking about what my environment is, what my operating system is. You start seeing that if you add proper security to your schemas, your test environment will somehow connect to your stage environment, because there's a small piece of code or stored procedure that actually looks for the other environment. But if you create environments for each one and create a deployment pipeline, these issues will pop up by themselves, because it will not work anymore. And it helps you eliminate and find bottlenecks. Most people think that a normal cycle is slow because of the development process. This helps you identify that. Maybe developers finish tasks in 2 days, and the rest of the sprint until a deployment is taken up by like improper QAing. And when I say improper, I mean doing a lot of exploratory versus automated testing. And everybody says it's not done because our definition of done includes all the steps. And it leads to a decoupled architecture. If you have a big monolith, a huge Java application or a huge .NET application that requires a lot of build steps, this will pop up when you build your continuous deployment pipeline. Because you'll see that you can no longer build stuff. If you want to deploy it, you'll need hacks to deploy it. So this approach favors smaller modules, and microservices especially. It favors them greatly. It's a lot easier to deploy and interconnect small modules than to build on legacy monoliths. It can be done, but it's really expensive. Okay, I really love this. So this is the cornerstone and key fact about this. So the normal deployment cycle considers deploying the application as a traumatic event. So it's like we need to deploy and everybody turns yellow and starts sweating because it's like, you mean you're touching production? When you do it continuously and autonomously, this no longer becomes a problem and it no longer becomes a concern for you. Because if the process works 1,000 times, it's going to work 1,001 or 2 or 3. And you also get more time. This process consumes a lot of developer and a lot of infrastructure time. When you do this, you get more time for testing, you get more time for discussing about various aspects, like requirements, like you even start wondering about usability, because you're not spending a lot of time on the nasty thing, you'll see the small things be uncovered. You get more sleep. You can do this as a schedule. The best thing to do is to do it like in your customer's downtime. So if you're working on another time zone, or if something is helping you deploy in a moment where there's not a million people doing that, like using your system, you can do it then directly without any issues. And If you say that, okay, we're going to do this at the start of the week instead of the end of the week, you'll win your weekend as well. So there's a lot of aspects that can help. You get more trust because, hey, it works every time. So you can be confident that when I deploy something, it's going to work. Again, it's a known process. And your customers start to trust you more. And you get happier customers. It's really nice to have a change request at the beginning of the sprint and to see it. If it's simple, you might even see it in the same day. So it all depends on how much manual QA you're going to do. But mostly, if it's simple, it's going to be in the same day. OK, I was talking about production continuous deployment. You don't need to do it. So you get the same benefits doing continuous deployment from development to staging as you do from development to production. And you can delay the production deployment based on business constraints. It's really good to do continuous deployment in staging and test it, and then do releases that bring more value to users and that make them happier, and maybe you can add more subscriptions or stuff. And you can get more money for the same effort. If you roll them out one by one, you might decrease the value of a product, and the user will think that he's getting all that stuff for free, basically. It all depends on the business, and you can do it directly to production in a safe way, or you can do it to staging and pack them up for production. It means that you're going to be able to deploy it anytime. It has a couple constraints. We'll discuss them when we go through each step. And yeah. OK, so pipelines. Pipelines are basically very, very simple. They're a series of steps with simple rules. This is a pipeline for a live website. It's like, I'm going to commit it. I'm going to see a webhook. There's a script on one of my production servers that's going to check it out. This only happens if you are using some really dumb static site. If it's like an enterprise thing, it's like this. And you're going to need a lot of patience to build it. The most important thing is that you're not supposed to do it all at once. Continuous deployment pipelines are not a project. If you start thinking about the new deployment project, you're going to lose 1 year setting up your continuous deployment pipeline, and it's not going to work. And in that time, you wasted every deployment. You should start with something small and then grow it to encompass your entire system. OK, if you're going to find a book, or if you're going to see a website that tells you this is simple, use the Go platform, not the language, the deployment platform, to have your entire application directly deployed into production. That's a lie. There is no recipe. It's like there's no one-size-fits-all pipeline for any application. You're going to need to think about it. You need to start small. So you can start, every system has components, even the simple ones. You can start with the simplest components and move up to the complex ones. And you should never skip it. This is a really important rule. Once you have a deployment pipeline for something, never allow manual deployments, because those will become the norm. If you start it automatically, and then you say, yeah, but it's a Friday, and we'll make an exception. Mike, can you deploy that? You can throw away your entire infrastructure then, because all the effort was spent on manual deployments. And you always need engineer-driven QA. This is, so I enjoy automatic testing and clicking frameworks, the ones where you record, like Selenium Recorder, and you record the interaction with the system. But those just build repeatable tests that let you know that those features you tested are OK. So that button that you always click as a developer and you record a test for will always work. Everything around that button might not. And there's no way to have 100%. So you still need manual exploratory engineers, like the guys that click that link they're not supposed to. And there's always a link they're not supposed to click, because that's how it works. and always have a rollback plan. And with the new things that we use, like entire infrastructures in Amazon, a rollback plan can be just dump all of the instances and bring them back up. So it's not really complicated anymore. Just drop that server, bring another up, and it works. So that's the rollback. We can start dissecting it. So as I told you, this is just a process. And it has gates. It has steps and gates, checks from time to time. These can be automated or manual. The goal is to have as many of them automated as possible, from version control check-in up to deployment in production. This is a gate. This can be implemented in any continuous integration product that is out there right now. So you can have the build go up to the creation of the artifact, like continuous delivery, and then have another step or another process that is human started, like deploy this into production. I was talking about version control. So this is basically, I talk about this every time. This is already, it should be redundant. So everything should be in version control. Everything. There's no reason not to have everything in version control. Except credentials. That's very, very bad. There's a project out there scanning GitHub repositories and sending them emails. You know, you have your database password in the configuration file in GitHub. So don't do that. You need small atomic commits. The smaller, the better. This is a discipline thing. Developers need to have a lot of discipline in their commits, like just committing one issue, or like just committing something that works from that issue. Because then you can easily roll back just those changes, and it takes 1 minute instead of 1 hour merging. So the process will fail. It fails a lot. When it fails, you just want to revert that last commit and let it run again. And that will fix the issue. And if you do trunk development, it makes things a lot easier. Because if you do that, then you only have one source or one version of truth. And that's the trunk. We're going to have a lot of time for questions because I was supposed to have a demo, but I don't. So. Okay, so it's about architecture and code. This is the first step. You can use like a big monolith application to do this, but it's better if you start out from scratch. So when you have a greenfield project, I know that happens once in a decade, but when you do have one, start from the architecture. Microservices win. They're not required, but they're the, let's say, smallest atomic parts that can be integrated. You need decoupled components, easily deployable. So your application should be made out of, let's say, start code, services, end code. They don't need to be micro. That are decoupled and that are very cohesive. Like this is that component that handles file upload to Amazon S3, or that handles transforming video, or that handles whatever your business is. Dependencies force larger pipelines. So if you have a big dependency graph between your components, like you're never going to be able to build a mobile application that is Android-based but uses some Java library until you build a huge server component. That mobile application will never be built fast enough or tested fast enough or deployed fast enough. So try to decouple things and to make dependencies as small as possible. Solid at the component level makes life easier. So use Solid as the ground for your growing code. Okay, build automation is required for this. So this is the keystone. There's no build automation, there's no continuous delivery, no continuous deployment. If you use something like you're writing a C# application and you're doing the build from Visual Studio, that's wrong. So that should stop now. It's very, very wrong. So building from the development environment, from your IDE, that's okay when you test something locally, but it should not be your build. Your build should be scriptable and it should go into build automation. You need to have reproducible, whatever the word is, builds. They need to happen the same way every time. If your build cannot be reproduced on a brand new machine taken out of the box, it's not good enough. You should go back and change it. That means that if you have, for example, how many of you are Java developers? Okay, Maven or Gradle? Okay, doesn't really matter, I was just curious. The idea is this: if you have dependencies that are created internally, like you have your own artifacts done by another department or in the same team, those need to go into a repository. It doesn't need to be a public repository, it can be a local repository, but those need to get there, because the next time you have a new team member, you're gonna start giving him jars on Slack. Take this and put it in C, my files, library, jars. So there's a lot of things, Artifactory, Nexus. You can even have a shared folder that is configured in settings XML for Maven that's gonna give them the correct version. Okay, you need build dependencies you can depend on. That means if you're using third-party libraries, you need a proxy. You need a repository proxy in your infrastructure that will hold on to those things at least 30 days. Because it's really easy to lose dependencies. And this is a valid thing when you're handling multi-year projects. So if you're doing something for a client that's gonna end in 1 month, you don't care, he's gonna fix it. But if you work for a company and you're expecting your position to last more than 1 month, you should be using proxies. What was it? The node fiasco, that one package that contained one function that was trimming files. That can happen to you anytime. Or if you're basing yourself on Maven repository, central hub, they might have a downtime for 1 day. They're really big. They might have a problem. And then if you have a 100 developer team, nobody's gonna be able to build. Because the way that works is that they're gonna check it, like the new versions, everything is going to fail, and that's nasty. It's better you have one proxy that works. There's open source versions as well. Test automation. You'll need unit tests. This is, again, if you're gonna do continuous deployment to production without unit tests, I don't know how that will work for you. Like, have a great time doing it. But it's, I stress on at least 50% method coverage. So it's like, I'm not talking line coverage, at least 50% method coverage, because that saves you from the most nasty errors, like somebody deleted one class. And then it will fail, because, okay, you're covering at least one method from that class. Integration tests are very important. The more integrated, the better. So you need to go to where the user is. So you need integration from the database level. If you have a mobile application, there are platforms that allow you to do full end-to-end testing. We're using Xamarin Test Cloud now, for example, testing like 200 devices continuously integrated. You'll need to create your own environment for that, like to have a test server for the backend services for the application, but it's okay. It's something that costs so little compared to breaking things. You'll need load tests as well. So changes, if you're gonna deploy to an application that has 1 million users, you might introduce small things like, if you're using Java, you can get concurrent modification exceptions for one wrong list type. So if you misspell one list type, you're gonna get a concurrent modification exception for one class. And that's gonna go directly to production. So you do need load tests. And UI automations, like I said. These are great process gates. So these are go, no-go situations. If something fails through these tests, you just stop it. Something went wrong, we're not even gonna deploy it for test, because that means effort for the test team. And you're gonna need QA engineers just for this kind of things. We had an issue where we deployed something that had a CSS bug, like a styling bug, that went all the way to production. So none of the gates caught the fact that the button was not there. So the button was just not there. That was one kind of media query in one style sheet that basically, let's say you have an application that orders food, and the order button was hidden for that media query. And we were like, but come on, look, all the tests are green. But the button's not there. Okay, all of this translates into CI. You're gonna get a win there. If you have trunk development, you won't have complex build scripts. This can be done using branches, but you'll get a lot of complexity there. This can be your continuous deployment driver. So if you have a CI server, doesn't matter which one, it can be the driver of the process. It can start everything else. All products can run bash scripts. And one of your build steps can be run this bash script that uploads the new APK to Google Play. So it doesn't really matter. Think Jenkins or Go. And for .NET, think TeamCity. Don't think Microsoft build thing. I don't know. It has a name. I always forget it because I hate it. Team something. Not TeamCity. It's like I'll remember. They have their own strange version control and their own strange build server. Not funny. Okay, there's no place like home. So like there's no environment like production. Everything is different. You need to have separate environments for everything. If you start a new project that's going to introduce so much change that you can no longer test, you will need another environment for that. So if you do something very, very differently, you will have test, stage, production, and very, very differently. The tool chain must know about them. So everything from your build up to configuration scripts must know that you have different environments. These builds are based on environment definitions. You don't want to deploy code that has debug statements to production, but you do need it for test. Same with logging and other instrumentation. You'll need that in test and stage, but you won't need it in production. So the build process needs to know what it is building. What about databases? So I'm always aiming for a production replica, always. There are banking situations where you are not allowed to know data. If you're in an environment that does not allow you to know people's name, gender, age, or how much money they have in the bank, you can use random anonymity techniques, like changing all of the personal details with gibberish. Doesn't really matter. But the entire environment will be as close to identical as possible. If you're running a clustered environment, you should add at least 2 of each, because you need to catch the clustered changes as well. You can bombard me with other questions at the end. You need setup and teardown scripts, or other things. So setup and teardown scripts are really dirty. You can create 2 folders in your version control and add up-down scripts with dates. And you can use this to update your databases. Migrations are better. They're in code. That means they're going to be type safe. So you can live with that. The best thing I used until now is database version control. And I mean things like for Java, it's in the comments. Leaky base. So for Java, I used something called leaky base, which was very good. It allows you to write one definition of up and down for each feature. And then you can say, a version contains these features. And it will know how to take your system from this version to the next by running different scripts. You can get a rollback as well. So instead of instead of just having a restore of a 1 terabyte database, you can just run one script that will roll back the changes that you just did. And integrations. When I'm talking about integrations, I'm mostly talking about payment gateways and communication tools. Those are the nastiest ones that I've encountered. And for these, you need to mock or sandbox them. So you're gonna need to, for example, for things like authorize.net, you get a good API. For Stripe, you get a good API. But sometimes you need to work with payment gateways that are not so friendly to developers, and you can just reverse engineer their API a little and create something that is just like theirs. And then you will be able to test as many times as you want, and in the environment and changes that you need. You need to use dedicated accounts for environments. I had a big problem with this. We were basically storing all the test data in the production Amazon S3 bucket. So, so you would get customer data mixed with test data, and then we had names for people in those files. And usually testers use funny names, like you're gonna have something like Beanbag Pete. Who's this guy? This is Beanbag Pete, and he has a new account in our bank. And what's his, let's say, what's his address? He lives on the street. So you would get, sometimes you would have a report that doesn't know that there's a bit called test data, and it's gonna include your test data in a report. And you're gonna have a nasty time about it. For infrastructure, we live in a time where, so I didn't have a project that was not virtualized for 6 years now. I'm proud about that. It's really cool. We used to have a lot of data centers, and we used to have a lot of failures. We don't anymore. We just use Amazon or Azure. It's not that cheap, but it's definitely cheaper. Because you get things like independence from it. You get utility computing. I want another environment today. And there's no need to call hardware engineers, system administrators. I worked for, again, a bank, and they had a Google, he was a Google specialist. And he was supposed to approve and create one Google business account for every environment. It would take a week. You need to request this form, and then you need to do this, and the Google manager, as a specialist, will sign off. And I don't know, this is much better. You can just mock those, and that's it. You have infrastructure as code. This is really cool. You get a lot of tools, everything from the light chef and puppet area with Docker and other nice containers, up to Amazon CloudFormation, which is awesome. So we actually get the CloudFormation recipes and put them in SVN with our versions. You get containers, packs, slugs. You can deploy Ruby directly without any issues. And lately, with Amazon Lambda, you can deploy Node.js without caring. So it's just, here is the package. You can be tested now. And it's easy to start over. Once you have a recipe done, you can redo your environment without any human effort. And that's pretty cheap. One of the things that are important is you will fail. I have failed a numerous number of times doing this. So up to deleting 500,000 records that were hand added by people. And the only thing that saved us was that Oracle had some kind of transaction log. And they were able to move the transaction mark back 500,000 records. I don't know how, that was magic, but it's okay. So it's gonna fail at least once. You need a rollback strategy. Because we have good infrastructure techniques, we can just recreate it. You need to think about your rollback strategy. Create complete backups, create incremental backups, backup configuration files, backup configuration scripts, daemons, everything. That needs to work, and you need to try it. So I'm gonna tell you something really, really weird. I was working for a company and we used Oracle databases. We migrated from Oracle 10G to 11. Like, let's say this is now, and we migrated 2 years ago. We did 2 years of deployments using data pump, but never knew there is a parameter called consistency until we needed to restore the database. It failed, like it failed as in one of the hard drives in the data center completely lost control and failed. And when we tried to restore that, we realized that every backup that is not consistent equals yes is not consistent. So you're going to get foreign keys that don't match anymore. And we were lucky just because there was one system administrator that was like 60 years old and that created disk clones on backup tape. And I was like, that still exists? And he was like, yeah, we have E Omega backup tapes, like in the 60s, yes, like in the 60s. And they did those 2 terabyte cartridges that were entire hard disks. That saved us. That was the only thing that saved us. So if you do backups, restore them at least once on a different machine. Because if you restore it on the same database, it's going to work. Okay. Can we talk about some of our stacks? Or do you have questions about this entire process? Because I'm really interested, and maybe we can have some fun discussing different stuff. Or anything that you would want to automate, because this would be a nice discussion. Yeah?
Just a short one. So it's very nice. I mean, we do want to have everything kind of, no, I believe I don't need it.
Okay.
I'm very loud. So it's very nice that you want to have everything, all of it, you want to kind of automate everything, but how long it really takes for us, how expensive it is, and do we really have time to automate everything?
So automating everything is like requiring 100% code coverage. So it's a step that you go through if you are in a controlled environment and if you don't care about money. So if you have money to throw away, automate everything. But if you don't, there are things that are Pareto based. So like you're always going to have things that cost 1 day but save you a month over the period of 1 year. So the first thing that you do, for example, if you do not deploy to production, because I was talking about version control automation earlier. The first thing that you need to do if you do trunk-based development is when a build is completed successfully, automatically create a tag. From that tag, you will deploy to production. That single step alone will save you the time of a developer or a deployment specialist or build specialist doing those steps. The time it takes to do it, for example, in TeamCity, 5 minutes. So that's for 5 minutes, nobody's going to have to go and create tags for successful build. And then you can show those tags in a list and say, that's what we're going to deploy. And the process becomes more time efficient for everybody. But you don't want to automate everything because automating everything is very expensive. You want to automate the low-hanging fruit, taking them one by one, the small steps. If you have a brochure website and a large application, start with the brochure website. That's like very low risk, but you might win 1 or 2 days per month from that. That's how can I say that? That might be thousands of dollars over the period of 1 year. Just not deploying that website. Anything else? No, I'll be around. You can ask me stuff. Thank you. Thank you so much.